Assalamualaikum dan selamat sejahtera. Today we go to the new subtopic which is 7.2 acid-base titration. First of all, you have to know what means by acid-base titration. A solution of accurately known concentration, is added gradually to known volume of solution of unknown concentration until the reaction, which is neutralization, is complete. So look at the apparatus that needed in acid-base titration. As usual, you need a burette and one conical flask. The solution in burette we call as titrant, and the solution in conical flask we call as analyte. This titrant can be as strong acid or weak acid, or can be strong base or weak base. Same goes to analyte, can be as strong acid or weak acid, or can be as strong base or weak base. From definition, acid-base titration, accurately known concentration is added gradually. That means for titrant, the molarity is known. Also, the volume also can be known. To a known volume solution added to known volume solution. So analyte, the volume will be known, while the concentration is unknown. So we can determine the concentration of this analyte. Titration process is titrant react with analyte in the presence of indicator to produce the complete reaction until equivalent point is reached. So this analyte will added two or two drops of indicator. What means by indicator? A substance that indicate the equivalent point of titration but its color changes. Di sini dia akan menentukan di mana berlakunya equivalent point. What means by equivalent point here? The point at which number of mole base is equal with number of mole acid. What the end point? Is it similar with the equivalent point? No. The end point is the point at which the indicator will be changed color. So here there are some acid-base indicators that we use. Normally we use phenolphthalein. Here we have three types of acid-base titration, which is strong acid and strong base titration. The second one is strong acid and weak base titration, and the second one is weak acid strong base titration. For the first type, the pH range is 4 to 10. pH range for equivalent point will be occur. You have to memorize this point. pH solution is 7, which is neutral salt. Suitable indicator is phenolphthalein, methylate, bromothymol blue, or chrysorite. The second type is strong acid and weak base. The pH range equivalent point is 7 to 10. Memorize this value. The pH solution, the salt will be produced is less than 7. The pH of the salt should be less than 7. Suitable indicator is methyl orange or methyl red. While for type number 3, pH range for equivalent point occur is 4 to 7. The pH of the salt should be greater than 7, and suitable indicator is creosote or phenolphthalein. Okay. Look at the first type, which is strong acid and strong base. Let's say I have apparatus, burette, and conical flask. Okay, the titrant is strong base and your analyte is strong acid. Okay, for example, this is NaOH. For example, your strong acid here is HCl. From this titration diagram, we can sketch, okay, a graph for titration curve. This is your P. Y-axis refer to pH of analyte, which is HCl for this case, and your x-axis is referred to the volume titrant, referred to NaOH. Okay. The starting point must come from pH 1 or 2 here, right? 1 or 2 at volume equals to 0. Starting point here. Why? Because before you added titrant to analyte, the pH in this conical flask will be referred to the pH of this HCl. We know the strong acid, the range of pH for strong acid is 1 to 3. So approximately sahaja di sini kita anggarkan 1 ataupun 2 for starting point. Di sini pH ini merujuk kepada pH dalam conical flask sahaja. Before you added titrant, that's why dia pada volume kosong, pada volume titrant belum dimasukkan, iaitu kosong, pH of the conical flask is referred to the pH of strong acid. When you starting added drop by drop titrant to the analyte, the curve will be increased gradually. At one time, the pH will increase sharply, produce steep part. Okay, steep part here refer to the pH range of equivalent point. As we learned before, pH range for strong acid and strong base is 4 to 10. This is steep part. Okay, garisan yang hampir menegak merujuk kepada pH yang increase sharply, even small amount titrant added to analyte. And at one time, the pH will increase gradually. So, this is titration curve for strong acid and strong base. Okay, let's say for the titration types number 2, I have a burette here and the conical flask here. Your titrant, okay, is strong acid, while your analyte here is weak base. Example, strong acid is HCl here, and example for weak base is NH3. Let's see. This is type number 2, strong acid and weak base. From this apparatus, I can sketch the graph, titration curve. As usual, Y-axis refer to the pH of analyte, which is NH3. And your x-axis refer to the volume titrant, which is HCl. Okay. Before you added titrant to the analyte, pH of your weak base should be referred to the pH of ammonia, which is weak base. So, anggaran pH weak base di sini adalah bernilai 10, 11 ataupun 12. So, let's say lah, before titrant added, that means volume titrant 0, the starting point here should be 11 or 12. So, next, starting point here. When you added titrant to the analyte, drop by drop, the pH of this analyte will be decreased gradually. At one time, the pH will decrease sharply. Produce steep part here. This steep part refer to the pH range of equivalent point that we learned before. Steep part for strong acid and weak base is 4 to 7. Okay, then at one time when you continuous added titrant to the analyte, the pH decrease gradually. So, this is your titration curve for type number 2. Okay, next for type number 3, which is weak acid and strong base. Let's say I have burette here and conical flask. Your titrant here refer to the strong base, and your analyte here refer to the weak acid. Okay, from example for strong base here, I use sodium hydroxide, and example for weak acid here, I will use ethanoic acid. From this apparatus, I want to sketch the curve, titration curve. As usual, your pH analyte is referred to the ethanoic acid, and your x-axis here refer to the volume titrant, which is NaOH. Okay, where is your starting point? Before you added titrant to analyte, the pH of the analyte here refer to the pH of ethanoic acid, which is weak acid. Anggaran pH untuk weak acid adalah 3 ataupun 4. So, starting point, before you added titrant to analyte, that means volume titrant is 0. The pH of the analyte is 3 ataupun 4. Anggaran di sini 3 ataupun 4. This is your starting point. When you starting added titrant to analyte, drop by drop, the pH of this analyte will increase gradually. At one time, the pH will increase sharply. Refer to the steep part. This steep part. This steep part refer to the pH range of equivalent point. As we learned before, Steep part for strong base and weak acid is 7 to 10. After that, if you continuously added titrant to analyte, the pH will increase gradually. So, this is your titration curve for type number 3.